Okay, in this question, we have a cubic polynomial here, a function f, in which the highest power of x is 3, and all of the powers are positive integers. So this is a polynomial of degree 3. In any case, the first question is to determine the critical numbers of f. Those are the numbers for which the derivative is 0 in this case. So f prime of x is, and now compute x cubed, the derivative is 3x squared, minus 6x squared, the derivative is minus 12x, plus 9x, the derivative is plus 9, and then plus 1, the derivative is 0, the derivative of constant. So we don't need to put it there. The 9, of course, is there, but the 0, no need for it. And so notice that 3 is a common factor. So I can put it like 3x squared minus 4x plus 3. And now I can factor this in an easier way. This is x minus or plus something times x minus or plus something. You need two numbers that multiply to plus 3, and when you add them, you get negative 4. If you think a little bit, you'll get that they are negative 1 and negative 3. When you multiply them together, the negative cancels the negative, it becomes plus 3. And when you do negative 3x minus x, it will give you the minus 4x. So this is why it works, and this is the right these are the right factors. And so f prime equals this. Set it equal to 0 to get the critical numbers, because this derivative exists everywhere. So if we set it equal to 0, we just get that either this is 0 or this is 0. So x is either 1 or x is 3. Those two are the critical numbers. So you can say, therefore, the critical numbers of f, are x equals 1 and x equals 3. What is so special about critical numbers? Why are we computing them? It's because local maximum and local minimum exist at them, and also the function changes from increasing to decreasing at them. So not all the time, but they are the candidates for this. So they are very important to find for any function. And in this case, 1 and 3. Let's study it further by answering part B. So let's see. In part B now, find the local maxima and local minima of f. Okay, so you draw a real axis and put the zeros of the derivative that you found, 1 and 3. You just found them in the previous part. And at them, the derivative is 0. That's what you found. That's why they are critical numbers of f. And so now, if you take a number less than 1, let's say you take 0 and replace it in the derivative, this will give you a positive number. So this is plus here. If you take a number between 1 and 3, like 2, you can take, and replace it here in this formula, you'll get 2 minus 1 positive, then 2 minus 3 negative. So positive times negative is negative. So the derivative is negative here. And if you take something bigger than 3, like 4, and replace the 4 in this formula, it will be positive times positive, so positive. You can do on your calculator the replacement if you want. And you choose at random any point less than 1, any point between 1 and 3. It doesn't have to be 2, but 2 is the most convenient, the easiest one. And then anything bigger than 3. You can even choose 100 if you want. All of them will give you the same sign at the end. That's what you're interested in. So whatever you get, just record the sign. And therefore, what happens to f? When the derivative is positive, f is increasing. When the derivative is negative, it's decreasing. And when the derivative is positive, it's increasing again. So this means that this one, the function at it is increasing, then decreasing. So it's a local maximum. And this one, it's decreasing, then increasing at 3. So it's a local minimum. We can delete this, yeah, and right here, it's a local minimum. This is the easiest way in this case to do it. If you want, the second derivative test also is important, but the reason why I did the first derivative test is that here they ask you find the intervals on which f is increasing or decreasing. So this you get from here. It's increasing where the derivative is positive. So you can say f is increasing on the intervals from here. F is increasing on, and then you have here from minus infinity to 1, union, it means or, more than 3. You are from 3 to infinity. If you want to include or not, don't include, just make it an open interval better. But it's okay if you include it also. Sometimes people do that. And f is decreasing on, and it's between 1 and 3 decreasing. So on the interval between 1 and 3. Sometimes people might confuse this with the point 1 and then 3 on the xy plane. In the xy plane. So in order to avoid this, some people use the interval notation like this, 1, 3, open, like in this way it's written. I prefer to write it in this way so that no confusion is there. And this you can write it in this way as minus infinity to 1, union, again 3 to infinity. Maybe better to write it like this. It's increasing on these two intervals and decreasing on this interval. Okay, and here they say if you have any inflection points, check in part C now. So inflection points, this you need to put the second derivative equal to 0. So what is f double prime of x? Where is f prime? F prime, I mean, writing it in this way is the easiest one to take derivative, easier than looking at this one. You see, you look at each one in the time that you need it for whatever purpose. So if you want to take derivative, looking at the derivative in this format is the easiest way. But if you want to study critical numbers and find the critical numbers, it's better that you write it in this format, so that you can see the roots or the zeros of this derivative. So, great. You should be able, of course, to switch between these two at any time, whichever one is more convenient for the question at hand. And so, now f double prime, just look here. It will be 6x minus 12. And so, if I set it equal to 0, I will get x equal 12 over 6, which is 2. So maybe I write the entire thing. So x will be 12 over 6, which is 2. And now we ask, is this 2 an inflection point or not? So you know that at x equal to 2, the second derivative now was 0. And if you take something less than 2, let's say you take 1 or 0, and put it in the second derivative. Let's say you took 1. 6 times 1, 6 minus 12 is negative, so you put negative here. Take something more than 2, maybe 3, okay, but in your head, yeah? And then put it back in the formula. 6 times 3, 18, minus 12, positive. So you say positive here. That's what? F double prime. And so f double prime controls the concavity of the function. So when it's negative, the function is concave down, like this, and when it's positive, the function is concave up. So because the function changes its behavior from concave down to up, or if it changed from up to down, in both cases the number in here will be an inflection point, because there is a change of concavity at this number. So here x equals 2 is an inflection point, is the x coordinate of the inflection point So if you want the inflection point in total, you put x equal to 2, so the inflection point is 2 comma the function at 2. You need to find f of 2, which is from here. You find it. F of 2 is, let's put it, 2 cube is 8 minus 6 times 2 squared, 6 times 4 is 24, plus 9 times 2 is 18, plus 1. So this will be, let's see, 18 plus 1, 19, plus 8 is 27, minus 24 is 3. So f of 2 is 3. And so the point here is 2, 3 is our inflection point. Remember this, because now we will draw the graph and check that what we have is true. And for concavity, you can say f is concave up on this interval from 2 to infinity. And we said that we will write it with this notation, from 2 to infinity, and concave down on, and it's down from minus infinity to 2. This, we just got this, that f is concave up and down here, and these two also told us that there is an inflection point at 2, and we found the y coordinate of it, it's 3. Perfect. And finally, let's solve this and then check the answers. So they say in the last question, find the area under the graph of the function f. Here is the graph between, at least between 0 and 5, you see the graph. So find the area under the graph and above the x-axis from 0 to 4, between x equals 0 to 4, the area. So this means that they want you to take this area. This is one side of it, then this here, and then from 4 up, and then all of this. It looks like a fish, by the way. So we want to find this area. Let's shade the area that we're trying to find. So here. This is the area they're asking us to find. And we know that the area is related to the integral. So this area, so you can say the area that you see, the shaded area, equals the integral from 0 to 4, from where you start on the x until where you end, of the function that is the function you started with, this function f, which is the one at the beginning here. That is the graph of this function, x cubed minus 6x squared. So you'll have x cubed minus 6x squared, and then what was it? Plus 9x plus 1. Plus 9x plus 1. So you integrate this function dx between 0 and 4. This is exactly the area that you see, the shaded area. The shaded area in blue. This is how you compute it. And so let's compute. So this will be antiderivative x to the 4 over 4 minus 6x cubed over 3, so 2x cubed, plus 9x squared over 2, plus antiderivative of 1 is x, and this is between 0 and 4. Notice the nice thing here is that when you replace 0, all of them will be 0. Nice to know. So first you replace, of course, the 4. Replace it for x. And so this will be, first we put the 4 in the places here. So 4 to the 4 over 4 minus 2 times 4 cubed plus 9 over 2 4 squared plus 4. All of this. Okay. Just look at it. All of this minus 0. When you put 0, you'll get 0 minus 0 plus 0 plus 0. Okay, equals, this is of course nothing. So the entire answer is just this. So let's simplify it. 4 to the 4 over 4 is 4 cubed, which is 64, minus 2 times 64 is 128, plus this one 16 over 2, 8 times 9. 8 times 9 is 72, and plus 4. And 4 cubed, this is 64, minus 128 is negative 64, plus 76. So 76 minus 64 is 12. This is the answer now. So the area is 12. That's the I did it by hand. Now we'll do it with a calculator to check. So let's check this one first, E first with the calculator. It's actually something that you can do with your Casio calculator, the one you have, because it's a definite integral. So you go from, we want from 0 to 4 of this function. So we'll put the whole function here. It was what? X cube, x to the power 3, minus 6x squared, plus 9x, plus 1, equals 12. Perfect. So this is telling us this is the correct answer. The area is 12. And let's go to the other ones. In fact, I can graph the function here. I can do x cube minus 6x squared plus 9x plus 1, and I say graph. Notice in the graph we will check all our answers. So here on the graph you can say check the extrema, local maximum and minimum. It's telling us at 1 and at 3. You see, 1 and 3. You have maximum at 1 with maximum value 5 and minimum at 3 with minimum value 1. And this is what we got. 1 is a maximum and 3 is a minimum, which is correct. And now increasing, decreasing, you can see that the function is increasing up to 1, then decreasing to 3, then increasing after 3. And for inflection point, you put inflection, you see the point 2, 3. If you remember, we already said it here. The inflection point is 2, 3. So you can check this again if you missed this part. And what else do we need to check? Yeah, we got everything, the critical numbers, and then concave up and down. Yeah, because the inflection point 2, 3, before it was concave down, and after it it's concave up, the function. And you can check this easily. It's what we got here when we said that it's concave down before 2 and up after 2. Perfect. This is nice to know that this calculator also can graph. And we checked our answer, and the area, we saw that it's 12, and we're done with this question, so I'll stop here.